Recording.
All right, it's recording. Okay, now, afternoon, everyone. My name is Dr. Greg Placencia. I'm an assistant professor in the Industrial and Manufacturing Engineering Department. I welcome you. And it's today's topic is one of interest to me because let me give you an idea of my background. I was originally a computer science major undergraduate, and after doing that for a while, I got into it's called natural language processing and also a bit of AI. Then eventually what would happen is I got involved with a project with some industrial engineers. This is at University of Southern California, by the way, when my graduate. And one of the professors there really liked some of the work I had done in computer science with helping one of his students. And he got me to get into a project with him that was on transportation. And as a result of that, I got into other little things of industrial engineering, including human-computer interaction, issues of user interface design. And I kind of got into a lot of more applied psychology simply because of that connection. Now, you may wonder why the two are connected, but you'll see as we go along that ideas sometimes are interconnected in ways we wouldn't expect. Now, as we go through this, I did want to mention that the idea behind this talk was that whenever, as engineers, one of the things I think that we forget as engineers that a couple of things, actually. The first is you can be surprised how much you can learn from history. Number two is when building a design, make sure you're answering the right problem, which means you have to define the correct problem to begin with. And number three, make sure that whatever you build, it's going to make sure it's going to last for a long time, because there's nothing more frustrating to see something that was designed to take countless hours to make up, and then suddenly it just at the end of the day just goes poof. So that's one of the reasons why when I was talking to several board members of the Engineering Without Borders team, I was mentioning some of these ideas, and I thought that after we talked a bit, they thought maybe I can talk about this, and I was more than happy to share what little I knew. And I think that as an engineer, I think that one thing that we need to really, really address is the idea of history in engineering. And you'd be surprised how often history can teach us very valid and important lessons if we only let it. And this is an example out of it. In fact, if anybody wants my notes, I'll be more than happy to share them at anytime. This is simply one note that I put together. And again, it's very, very simple, just to keep me prompted. But every time I talk to students, several stories pop up. I usually tailor it to what I talk about, but one of the most prominent ones I think about was called the Iraqi chicken processing plant. And the reason why I mention this is because there's a book by the name of We Met Well. And it's basically a retrospective of a contractor who happened to be in Iraq after the Second Iraq War. And I'll never forget this particular example, and I looked it up and I tried to find some background on it, but the idea behind this was the American rebuilding effort wanted to build a chicken processing plant in Iraq. And the reason they were thinking about it was, well, it was relatively expensive to get chicken from Brazil because they were importing frozen chickens from Brazil. They thought, why that Iraqis might enjoy much more having fresh chickens that were dispatched in Iraq, and as a result, it would be available to them. It'd probably be cheaper and all this. Well, what happened eventually was when they built this chicken processing plant, it came out actually more expensive than the chicken they were importing from Brazil. And the reason for that is because of all the infrastructure and other things they had to build just to get the chicken processing plant in place. And let me bring up this little section here, because eventually what they found out was that one, you can't have a chicken processing plant without making sure the chickens keep alive. And to do that, you needed air conditioning. Well, to do that, you needed to have an electrical power grid that was reliable. So they had to build all that. Then on top of that, you had to have a reliable way of transporting it, transportation problem in industrial engineering. They had to build the roads to get there. And so by the time they built all this, as I was mentioning, it was more expensive than the chicken they were getting over in Iraq and in Brazil. But it came out that they spent $2.5 million to build this chicken processing plant in the middle of nowhere that unfortunately only processed, from what I understand, only processed a few chickens just for a VIP visit. Now, I don't know about you, but I'm sure several of you would have loved to have a portion of that $2.5 million to do some of your work. This was back, like I said, this is 2011, so probably more towards the early 2000s. So I think all of us would not mind having just a little portion of that 2.5 million that went to waste into this factory that's basically just sitting there in the middle of the desert, just degrading now. So I just wanted to mention that. That's why when I was talking to the team, I was mentioning the idea that when we're trying to make solutions as engineers, we really have to think about what is it we're trying to accomplish? What is it that's important for us to do? In this case, it's some person to say, hey, that's a great idea. Let's build a chicken processing plant. And it'll be cheaper in the end than going to Brazil. And if I remember correctly, at the end of the day, Brazilian chicken, frozen chicken, yeah, it was $1.88. And by the time that they built this, it was like almost $3 per chicken. So we're talking about $1 more to build this for chicken in the plant, which no one wanted. It was halal and all that, but no one wanted it. So very sad example of that. But there are many examples out in history. For example, another one that I talk about in my class in engineering economics is about the space shuttle transportation system, the STS. When it was designed in the late 1960s, it was designed to be basically a space pickup. They were going to be delivering products to orbit very cheaply, or I should say low Earth orbit on the shuttle. They would have a system in which to push it up into higher orbits or into other trajectories or wherever they needed to. And eventually, sadly, this great idea did not come out as well as they thought. And I don't know if any of you know this, but originally the idea was to have a shuttle launch about every 2 weeks. And we never came even near to that number. I think the best we ever did one year was about maybe 11 launches in 12 months. So it tells you that it was a great idea, but unfortunately, after all the technological hoops, did not work well. And sadly, we lost 2 crews on that, the Challenger in '86, if I remember correctly, and also the Columbia in 2001. And we're talking about 12 people on the system. And in fact, we almost lost the third one, but for strategic loss of a heat tile. So when thinking about these solutions, please, that's what the impact of this would be. But one thing I did want to mention from that article that I showed you was this part here. And their goal at the point was to put more protein to the food chain. And also they wanted to, and notice how they say they measure the impact of our project by their effect on us, not by their effect on, it was the word missing from the vocabulary of developing Iraq. Everything was measured only by what we put in, dollars spent, hours committed, people engaged, press releases written. And that's a very psychological thing that we do is we count the output as being more towards what we get out of it than actually what the real output is. And today, as we talk about the first part of this, the establishing decision criteria, you'll see that there are ways to be more objective about our decisions than just saying, oh, we'll do this. And before I continue, any questions or any clarifications anyone would like? Okay, I guess I'll take that as a no. And again, I'll make these available. This is to Al Jazeera. And also, if you ever want to read the book that I mentioned, it's actually online for that. So the model I want to use is, and I learned this actually when I was a graduate student, and I sometimes think it's very sad that undergraduates are not required to take this class. I think it should be a required engineering course, is in decision theory. And what I teach, particularly at Cal Poly Pomona, is a subset of that, which is called engineering economics. And the purpose of engineering economics is to deliver sound economic analyses to a decision. And so based purely on numbers, you use that, and whatever numbers look better, whatever rate of return looks better. Rate of return is for every dollar invested, how much money do I get back? which one's best. And what the method I learned from my professor was called the PROACT method. And what PROACT stands for is, as it says here, problem, objective, alternative, consequence, and trade-off. And I'll spend most of the time talking about that today, but please feel free to ask me questions as we go along. But the idea is that you start always on the problem you're trying to solve, your goals and things like that, before you even start deciding on a solution. So for example, I was working at Children's Hospital on a project one time, and I was working with a certain unit there, and I found out that that unit, what they would do is they would fax orders to another department. Now, mind you, this was only a couple of years ago. And was really difficult and weird about this whole deal was to hear how they were going on. And they were talking about that when they had to deliver orders to other departments or therapies, or they had to deliver orders, they would always be sending them via fax. So a question would be like, okay, why are you sending it via fax? I mean, and I guess the reason was because that's how they had always been doing it for the longest time. But then the question would be, very simply, what happens if the fax machine goes down? Do you get a new fax machine or not? I mean, what do you guys think? If I'm trying to get orders to, if I'm trying to transmit information to different departments, or if I'm trying to do it between different companies, and I've been using a fax machine forever, do you think that would be a great alternative? Or should I go and get a new fax machine if that goes down? What do you think?
Would it maybe be time to upgrade to a new system instead
Maybe.
of fax?
Exactly, maybe. Anybody else think about it?
Maybe email it instead of faxing it.
Okay, possibly email. I mean, I suppose they could use a someone, a courier somewhere if they wanted to. But notice something about this. The issue was transmitting information from one department to another, wasn't it?
Yeah.
Yeah, it wasn't about the fax machine. It was about getting the information from their department to another department in order to make sure that treatments and what was needed to be done was done correctly. So when they made this idea behind having the fax machine, under normal circumstances, and most businesses would just say, okay, the fax machine busted, so let's get a new fax machine. I don't know, but it's kind of hard to find. I mean, you can't find a dedicated fax machine these days. You might find it integrated in a lot of printers, but even now printers are starting to remove the fax option from their systems. But as you said, Clyde, right? Is that correct?
Yes.
Like you were saying, Clyde, maybe we need to investigate in using email, or like you were saying, Zachary, maybe we need to figure out another option. Well, the only way you can actually do that is by asking yourself first, what is it that I'm trying to solve? And oddly enough, out of curiosity, are any of you thinking about going to graduate school?
Yes.
I'm debating it currently.
Okay.
I'll make that decision when I graduate with my bachelor's.
Okay. Are you thinking about at all PhD?
Just master so far.
Okay.
Yeah, PhD is kind of far.
The reason I ask about that is because in reality, the heart of getting a PhD is asking the right question and solving it. So if you ever think about it, that's what it basically a PhD. I mean, it does take time. I'm not saying it doesn't, but basically the basis of getting a PhD is asking the right question. It's got to be an important question, obviously, or something that's important to work, but asking the right question and solving the problem. So for example, are many of you familiar with the fact that they're starting to build 3D houses? You heard about that?
Yeah.
Okay. One of my advisors was a professor that was one of the key people that started a lot of that movement. He got the idea because he was back in Iraq, and there had been a massive earthquake. I believe it was in the city of Bam. But the thing is, he said, well, what could we do if we could build areas, be able to build some type of places for the refugees very quickly and without much problems. Well, he had been working with 3D printers, the early 3D printers in the 2000s. And he thought, wait a minute, can we apply that to another situation? And so one of the problems they had to solve with that was how to develop out an extrusion material that was capable of building these type of houses. And one of my colleagues, one of the people I was working with, he actually got his PhD based upon figuring out what was the best way to make this material as a concrete type material in order to extrude it correctly. So the basic problem started as, how do we get housing there? Well, it's the same thing with anything we might be doing. I mean, with all the work that EWB does, asking yourself, what is the actual problems we want to solve? So like we were talking about some of the projects. Do we have a reliable water source within a village? Do we have a, like example, we're talking about solar panels. What is the reason for a solar panel? Are we trying to get reliable electricity and reduce other footprints and all that? If the problem is that we're trying to give electricity to teach, maybe we ask ourselves, how can we teach? Oddly enough, remember there's a thing called I forget the official movement, but basically what they're trying to teach is don't code on a computer, learn how to code off of computers and then get on computers. So the problem is, how do we teach good algorithm, making good algorithms and good instruction sets, not to just code on a computer. So the idea behind the problem is, ask yourself a simple problem we need to solve. And so that's one of the things I was trying to get across, was that to solve the problem, we need to figure out what that problem really is. For example, in the chicken processing plant, as it says, they were trying to get more protein to the diet of the average Iraqi. There could have been many ways to do it. If you guys, like, what do you think were other ways they could have gotten the protein to the Iraqis?
Protein shakes?
Protein shakes, okay, possibly. Others? I mean, it sounds kind of a weird little thing, but it's, so, we'll get the solutions alternatives later. In fact, actually, I'll do that.
Send them some chickens.
Right? I mean, the alternative, the do nothing might just work well. Send them chickens, frozen chickens, right? So they had already done that from Brazil. So maybe that's called a do nothing alternative usually. But the idea is, yeah, just keep going the way it is. And we find out that probably what they were doing was probably a way to do it. Are any of you familiar with some of the drives to use insect-based proteins?
No, I'm not.
No.
Okay. Yeah, the reason I ask is because in many cultures, especially Asian and also ancient Aztec cultures and many Mesoamerican, they actually would eat insects. In Mexican culture, there's something called chapulines. And chapulines are basically fried grasshoppers. I had them. They're very interesting. I guess they have the texture, live crickets. Okay, yes, exactly. If you've ever tasted a peanut and seen the skin on peanuts, it kind of is vaguely reminiscent of that. And the ones I had were basically in a bit of salt and some chili powder. Not bad, actually, just kind of got to get over the first reaction of eating it. Other things that have proteins, many insects have proteins. And in fact, many countries still give insects as a form of protein. And for the longest time, insects would provide protein for many cultures. And so maybe insects could have been something in the area. I don't know. I'm just saying that if you're looking for a solution, yes, exactly that, Zachary, plant-based too, definitely plant-based. But the reason why I'm mentioning this is because, you see, in that problem that they had, it just sounded good. Let's make a chicken process. There is a very concrete example of our work in that plant being there. But when we get to just the basic problem of how do we get more protein to the Iraqis? Maybe the solution they thought on wasn't the best one to start with. Maybe they should have started thinking about other aspects based upon their first thing of getting proteins to the Iraqis. Now, when you do that, the next aspect of usual problem solving is called your objectives or goals. So, and the only reason why I put the way they have it is because actually Dr. Keeney, they developed out the idea of PROACT, and it doesn't have to be that because there are definitions of it. But what's nice about it's easy to remember PROACT. But the points are, after you get your problem, you start asking, what are your objectives? Now, you remember when we talked about the fax machine from that children's hospital I was mentioning? When you have that problem about getting information, you might have to ask some things about, what are things that I need to have as my constraints? Like, for example, I mean, a very common one. Let's see, Justine, were we the ones that talked initially? I know Zachary, you and I talked, and we had that talk there. Some of you with on that call, we were on that Zoom conference when we were asking about the projects, correct?
Yeah, Justine was there too.
Okay, well, which project? Because I think, Justine, you talked about the local project with the solar cells, correct? If I remember correctly?
No, we were talking about the gray water project before.
Okay, the water project, yes, I remember that one. I thought there was a local one.
The cost-effective structures in which we.
Sorry, your voice is a little bit low.
Sorry, the cost-effective structures in which we improve the design that's already in place with the TJ house.
Okay, thank you. So when we're dealing with things like this, one of the things that always got me interesting about water projects was the idea behind a water project is basically provide potable water. It doesn't have to be, but most of the times you're trying to get potable water to a location, meaning you can drink it. If it's not, then there might be other alternatives. But the point behind objectives and goals is you're saying, okay, I need to figure out what are the constraints that I need to worry about. We go back to the llama. The llama was supposed to guard animals, guard the flock. It's interesting when you're having this discussion in class, we had many interesting solutions or alternatives they were mentioning. One was weaponize the llama, weaponize the sheep was another one. Others said get students out there for extra credit from classes to guard the sheep. All over the place. One person even said, let's put students in llama outfits to guard the sheep. And it got really silly after a time. But the point was they were looking at just all the alternatives, and as funny as they were, they need to go back to the idea of why we need to have something like a llama there in the first place. Why not just get someone to guard or something like that? Well, the objective was to be as sustainable as possible. Well, that's a lot of other things that we see in this. In the objectives for the processing plant probably was when they wanted more protein, the Iraqis, well, it's because they probably wanted to be healthier. But what they didn't say were things like probably, okay, we want to make this cost effective. Which is basically, let's make it cheaper than the cost of frozen chicken from Brazil. Or let's make it more accessible that Iraqis can get it more often or something like that. They could have had any number of goals. I'm just guessing the first one was cheaper than Brazil. Okay, but the idea behind getting your objectives is always asking yourself, once you get your problem down, is what are the constraints of my problem? Now, what are some of the different disciplines in the room today? Like I said, I'm computer science, industrial. Others?
I'm chemical engineer.
Okay, so I'll take yours for right now, Nicholas. So when you're a chemical engineer, I mean, you got to figure out what's going to be your yield, right? That's maybe one problem, right?
Right.
Okay, so you're not going to, I mean, if you're trying to figure out something, you're trying to make sure there's a reaction, you want to make sure that if you need a certain yield, you need to have a certain number of raw materials at a certain weight and purity and all that to be able to make the target goal, right?
Correct.
That's an idea of the objective. Other disciplines?
Yeah, I'm civil engineering.
Civil, okay. So, and I'm sorry, Daniel, but for whatever reason, I keep being reminded of a friend of mine who was a civil engineer. I think he said, what's the difference between a construction engineer and a civil engineer? And he said, civil engineers build targets. So every time I meet a civil engineer, I think about him. But anyway, but you want to build a structure or whatever you're building. I mean, it depends also. Is there a particular branch that you're interested in, Daniel?
Yeah. Water and environmental.
Okay. So what are some of the things you have to deal with when you're building? Like what are some of the things you want to make sure when you're dealing with any of the water things that you deal with?
That it's gonna last at least 30 years, 20 years, a few decades.
Okay. Anything else?
Environmentally friendly. That's not gonna cause problems on the line.
Okay. So again, those are objectives when you deal with any water project that you have. Aviation. I mean, I'll go on with this, but like aviation, it's interesting the different types of aviation parameters. So like if you're going from, let's say, a project like the SR-71, which dripped like a sieve when it took off, but basically the reason why the plates were so, the SR-71 was a huge, massive airplane, very fast, going Mach 5 plus. And the reason why I mention it is because when it took off, it had just enough fuel to take off, but it was designed to fly faster and farther and higher than any plane, or faster and higher than any plane. Beautiful piece of engineering. The only problem was that you needed to have it immediately after takeoff, you needed to get it refueled. Well, the reason for that is because once it got up to speed, the plates on the plane would basically seal in, and therefore, because of the heat, they would seal in, and therefore they designed it so that when it took off, it very loosely fitting, and so it would leak a lot of fuel. Well, that was the solution they had for this particular one. Probably not a good one for now, but at the time, we're talking about late 50s, 1950s, into the 60s during the Cold War. This was the pinnacle of engineering. Beautiful design, amazing. They're dealing new type style, obviously, but that was their solution for that, but it wouldn't work now. Nowadays, we talk about fuel efficiency. Those are objectives that we deal with. And so the ideas might change depending upon what problem you're solving at what time. Nowadays, sustainability probably is a much bigger thing. And that's why I'll put it even as an objective. And again, this is just very loosely built. But the point is, notice we've gone through what's the problem we're trying to solve and what other objectives are we trying to get. And that's why I mentioned it. And it's only after you start defining these problems here that you start getting to your alternatives. What are the actual things you want to do to solve these? And so, like we mentioned before, we have protein shakes. We could have gotten frozen chicken from Brazil. We could have insects. We could have plant-based. That's actually pretty much what we're seeing these days. There are different types of ways that people are trying to figure out solutions for protein in different countries around the world. With the growth of many markets in India and China and even Africa, you're seeing need for different types of diets. And unfortunately, our processed diet in the US like that is not done as very good. But at that stage, you can put all the different alternatives you want. And it's just the idea of we try and see from those basic alternatives, which are the ones that we think are viable. And there are many techniques to go through these things, but these two are always at the heart of our issue. What's our problem and what's the objectives? Because then after you establish those well, can you start doing with alternatives? Now, before I continue, any questions or comments or things like that?
So in order to set an objective, you're saying you have to be aware of your target goal.
Correct. Correct.
All right, just clarifying.
Like, Daniel, I'll take your example again. So for example, it's probably not going to do you well to grow rice in California, Southern California. Rice needs an awful lot of water to be able to be viable. But if I wanted to grow things that were low water, such as cactus and the like, probably a great alternative.
Right.
So yeah, Go ahead, Danny. Sorry.
So I was just agreeing. Yeah.
Okay. But it goes through whatever. I mean, and I want you all to remember this, regardless of what your discipline is. This is the idea of decision theory is let's build a good decision based upon what we're trying to achieve. You'd be surprised how often people just get the alternative simply because it was easy and to put in, but in the end, it causes a lot more problems. And that's why, again, when I was talking with the board, I was trying to say, okay, what are we trying to achieve? How are we making sure that it works out right before we even go on with it? And that's why when they asked me about this idea, I wanted to go with it and explain how we could do it in different ways. And again, this is one way it's done, but it's fairly common. So once we develop out what we want to do with it, the next part will be the following. What do we got for consequences? See, consequences are often forgotten when we do a lot of our work. Let's face it, okay? I remember, I'll give you some examples from my days. When I was working in coding stuff, I remember one time, actually very interestingly, it was one of the early semesters. It was my sophomore year. And we were working, I believe it was in object programming, object-oriented programming. And I'm not sure if any of you are familiar with object-oriented programming. Anybody?
No. What is that?
Okay. Object-oriented programming basically is a form of programming in which when you build it, you create objects and associated methods to those objects. So like, let's say I wanted to make an object to store data. We'll call it a book. And so a book might consist of a class for a book would be, it's an object called a book, which is basically, this is the material. But in a book, you can open it, you can find page, you can copy material from the book. And these are all associated with the part of being a book. So object-oriented programming was designed to make objects that allowed you to perform different functions. So like for you, Nicholas, since you're a chemical, you can maybe make a molecule. An object would be a molecule, and you can have all the associated parts with the molecule. You could, let's say, I guess, again, you and correct me if I'm wrong, Nicholas, please, but I'm guessing like, let's say polarity, or let's say atomic weight, or different things like that. Or you can even make it, maybe call it an atom, something called an atom or something like that would have the atomic weight. And then you could make a molecule from atoms and things like that, which would be another object. But the idea behind all this was to develop out different objects that could be used to do programming. Well, the problem was that when I was building this and I was working with my partner, we had what's called a memory leak. And what a memory leak is that you're using more memory and it's basically not self-contained. It's flopping over into other areas. And without getting too technical, let's just say it's bad to have memory leaks, but we were never really taught to worry about that type of stuff. Just said, get it done, get it performing as supposed to. And then the professor said, well, you should take care of this memory leak because in industry, it's actually bad. So we had to go back, figure out why the thing was leaking. We found it eventually and it made it work better. But the point I'm saying is that the consequence of bad programming like that is that you have programs that are open to bugs, because bugs are often related to having little consequential items out in the background that people are not usually aware of, but that programmers and actually hackers and crackers are able to exploit to do things. So they'll put in malicious code into an object or something like that, or they'll spill over into an area of memory to reserve for other instructions so that they can open it up to them. And there's a lot of stuff involved, but the problem was that because if we had not learned from that professor to close such memory leaks, that could be bad consequences down the line. And it goes with a lot of other things. For example, I'll go back to this one. So the consequences, the consequences of not building would be more expensive. So that was one thing that we talked about. It was just more expensive to have chicken from Iraq because the process just was not going there. Other things like I keep going back to water because water is such a primary issue. As I was talking about with the Chiaka system, Not having water in a region, or at least a standardized amount of water which you can rely on, could cause the massive failure of the different types of crops and even loss of people within an area. So the consequences when you're building these things, always asking yourself, okay, well, what are some things that will result if we leave it there? For example, I have nothing against solar panels. Believe me when I say that. I think they're great technology. But remember, if you have solar panels, what else do you usually need for solar panels if you're going to have a reliable source? Like if you make, let's say, not only sustainable, but reliable. Okay.
Good weather.
So if you have solar, go ahead.
Good weather, like consistent sun.
Correct. I mean, you're probably not going to build a solar plant in, let's say, Washington State, because Washington State is notorious for not getting sun, like you were talking, Zachary. You know, it's not going to work very well. Southern California, Arizona, parts of Spain, although there's an interesting aspect with the plant that they build out there. You need a reliable source of energy, which is the sun in this case. So if you don't get it, you're going to probably have problems. But anything else, actually, something maybe even more important than just having a reliable sun source.
Maintenance crew, like a weekly maintenance crew.
Okay, possibly maintenance. Okay, I'll give you a clue. And this is actually one at the heart of why solar panels have not worked as well as people anticipated. If we have solar power, is it available, even if we have a reliable source? Okay, good, Zachary, electrical infrastructure is another possibility, yes. But let me ask this question, go ahead, kind of dealing with what you mentioned. Even if you have a very reliable sun source, is it foolproof?
No, it only gives us power half the day.
Exactly. You need something to store it, don't you?
So a battery.
Exactly. Batteries can be a very, very difficult problem with solar energy. And that's why I was saying that although, I mean, I have no problem with the technology, it might need additional infrastructure or other things in order to maintain it. So for example, in the Iraqi chicken processing plant I mentioned, it became more expensive because number one, they didn't have electrical infrastructure, like you were mentioning, Zachary. It was difficult to keep the chickens because they would also have problems because they need to be cooled, not just because of storage for the meat, but also the chickens themselves tended to die if it was too hot. And from people that I know of the area, they say probably you can get as high as 120 degrees Fahrenheit. So 40, 50 Celsius is not a good temperature to keep chickens. But the idea with the consequences is you ask yourself, okay, if I build this, what other things will happen as a result? And it kind of goes into trade-offs, which I'll explain a little bit, but you have to ask yourself, are there other things that might result that cause a problem? I'll give you a more clear example of this. Dam, hydroelectric dam. So if I build a hydroelectric dam, yes, I do get electricity. It's renewable. But are there consequences if you build a hydroelectric dam?
You restrict water from some other area, perhaps?
Possibly, yes. That's one possibility.
You might kill off some species.
In what sense, Daniel?
Like for instance, like salmon up in Washington and Oregon.
Okay, yeah, you're right. That's been a problem. You reminded me, Daniel, of the salmon shooter.
What's that?
You never heard about the salmon shooter?
What's that? No.
Okay, you guys are probably going to find out weird things, but in Washington, what they have is basically the salmon are able to go up into, that's not it. I'll have to find it later, but basically they have this thing that salmon are able to go into the chute, and basically it sets the salmon up. So it jets them up kind of like a roller coaster, and it shoots them up the salmon cannon. Yes, thank you, Zach.
Oh, okay. I thought you were referencing like a shooter, like a person shooter. I'm like, oh, well, no.
No. Thank you, Zach. Yes, correct. Zach, the salmon cannon. So basically, yeah, I'm guessing, you've heard of those, Daniel, I'm guessing. The salmon cannon?
Yeah, I've seen that before. Yeah, they barely fit in there.
Right. But basically, you had to worry about making an alternative because they basically blocked their normal pattern of migration. So they had the consequence. They had to ask yourself, okay, if we have the consequence of salmon can't go up, then they were going to have to fix something else. How about floods? Flooding behind the dam that normally wasn't a flood area.
So you have to like keep in mind the space the dam takes. Is that what you're talking about? Like
Exactly.
it's a lot of space.
Now, yeah, I mean, I think you mentioned, Daniel, you might have to worry about its impact on other species, but that could be involved with the area behind the dam because you have to store a lot of the water now. But you see, and please, if you guys I think I'm incorrect, please tell me. But the point is that if you build a dam doesn't just exist. There are other things that will happen when you build the dam. If you make electrical storage using solar power, there is something else you're going to eventually have to do with it. And there are other engineering aspects like life cycle impact analysis or life cycle analysis. But the point is that whenever you build something or whenever you devise a solution, there will be consequences, good and bad, involved with that. Now, I know we have an hour and a half, but I'm going to try and cap this off any talks and we'll reserve the rest for questions. But lastly, what we have was what's called the trade-offs. Now, trade-offs are interesting because all choices have trade-offs. Now, a trade-off would be like, for example, interestingly enough, how many of you have actually been to the Cal Poly campus?
I have.
Okay, you have, Nicholas? You have, Daniel? Okay. Zachary? Okay. Now, the reason, okay, you have Jacqueline. Good. Okay, Justine, sorry. Anybody not been there? I should ask the opposite question. Anybody not been there yet? Here's the reason why I asked. Cal Poly Pomona is considered, for the most part, what's called a commuting campus. And that's what it was before the whole deal with the current situation that we got. It was not uncommon for me to have students come all the way from places like Barstow and Hesperia, obviously Riverside, etc. So the trade-offs that they had to deal with were having to go all the way to campus or finding places to live close by to campus. Now, a lot of people would live in Walnut and the like, but the point was that the trade-off was, if you want a place that's cheap relatively, are you willing to drive for it versus live something that's more expensive and be closer by? So you're always trying to figure out what is it that's important to you. Like the classic example I used to hear about was that if a person wants to live at the beach, or at least be able to go to the beach every day, and that was their goal, would they be willing to pay more money to go to the beach and stay at a housing at the beach, which is very expensive, depending on the area, or would they be willing to live within, let's say, 5 miles of the beach where it would be cheaper, but relatively okay to get there without too much problem, even if you use like public transportation? These trade-offs are things that we constantly have to ask ourselves. Am I willing, if I can't, usually it's asked because if I can't reach this particular goal, but I can use another solution that gets me to a place that I can reach it, it's just I have to add additional issues. Is the trade-off worthwhile or not? And there are a lot of different ones like that. For example, like with the Iraqi chicken farm, the trade-off would have been between having frozen chicken and fresh chicken, maybe. Well, depending on how they do it, I guess, some frozen chicken will be all right. Or maybe they'll make a synthetic chicken byproduct that they're, how they're trying to make beyond meat and all that. I don't know, have any of you tried that stuff? Because I have tried some of it. It's not too bad. Remember one time I was over in, I forget the name of the city, but they had a Chinese restaurant and they made this, it was a synthetic chicken dish. I forget the dish, but it was interesting to try it. It kind of had the texture of it, but it wasn't all that great. You had to have the sauce to make it even palatable. And the same thing goes for things like soy dogs and stuff like that. I've tried them out of, not out of just wanting to try it. And believe me, it's funny, when you get a veggie dog, it requires an awful lot of ketchup to make it believable. But yeah, I agree, Zachary. Beyond the impossible, we're getting very, very decent in terms of replicating the texture and all that. But the point is that, that's where they're trying to minimize the trade-off aspect. Although it's interesting, Zachary, because if I remember correctly, Beyond and Impossible are almost the same caloric amounts as regular beef and other things like that. And so it gets kind of interesting how it does affect the people and things like that. But again, the idea about trade-offs is that you have to go figure out what you're willing to not sacrifice versus what you are accepting sacrifice. So the trade-off, fresh versus frozen, like that might be an example of a trade-off. But going back to the things that you have at EWB, again, the point I was trying to make was that make sure I was a little bit concerned of hearing the solutions already without understanding the problem, because as I was mentioning, this was really interesting to me because this type of system, the chocolate system, was a way to deal with the issue of drought. And these areas are very, very arid, and yet some of the solutions they've got are amazing. Or, for example, another thing I've asked about is what's called the Chinampa system over in Mexico City. The Aztecs used to practice this system in which, because they had built a city on top of a lake, and I might as well explain it. The reason why, if any of you ever look at the flag of Mexico, you notice on the flag of Mexico there is an eagle on it. And what's interesting about it is that the background behind this eagle is that the Nahua, which are the people that were going there, there's a history that they say for, I believe, 100-some years or so, they had been moving around, and they were told basically by a seer that had a vision that when they found the location that had an eagle resting on top of a cactus, eating a snake, having a snake in its beak and eating it, that would be where you built your capital. Unfortunately, they found this said eagle, so the story goes, in the middle of a marshland, which is what Mexico City is built on. Basically, it's the former marshland of five lakes there, of only one exists now. It's called the Lake Chicoco, I believe it is. So what happens is that the idea was they had to do something very much like the city of Venice did. They had to put pilings, but to help people also, what they would do is they built these chinampas, basically, which are these big floating mats. And what's amazing about it is not only did they solve the problem, but they had a city of about 500,000 people in the middle of a lake, and they were able to sustain them because the chinampas had yields of 4 to 5 times per year. So they not only solved the problem of having people in the middle of a lake, including huge temples, but on top of that, being able to sustain a vast population with a good agricultural system and fresh water because they're aqueducts. That itself is also interesting. So they used a dual pipe system in order to maintain a fresh water supply. But the point was that whenever we're talking about this, you always first go back to your problem and then ask yourself, is this alternative acceptable for the problem, or am I getting invested in the solution, the alternative, before I actually figure out what I'm trying to solve? Because to finish what I was going to say is, I'll give you an example, a great example from one of my professors. My advisor once was working with the US military, and they had this suit, and this was supposed to be for chemical biohazard suit. And so what they did is they had like this readout meter on top. And the problem of the readout meter was that because they had these huge gloves on them, they could not really tap given the way the meter was on their arm. Well, they were asking him, do we make them bigger? How do we put them in together? When we do all this? And he looked at him and said, well, why don't you just use a stylus of some sort? So you make it smaller impact area, and therefore you can fit in a regular interface. And indeed, that was what they did, because they, instead of trying to redesign everything on the arm, They basically just made it so that the implement was able to do the information input that was needed. So much cheaper than all the development time it would have taken to do all that. Putting a bigger screen would have been much more expensive, and a lot of other things would have happened. But at the end of the day, he said, what's your problem? Well, getting data, putting data in the screen. Okay, what are some of the constraints? Well, we got this huge glove. We can't take it off because we're in biohazard conditions. Oh, so what do you got? Well, we make it bigger screen. We do this. Why not just change it so the alternative is a little stylus? What's the consequence? Well, it's actually cheaper. It actually came out to be much better because they're able to go it. They're able to just touch it with a stylus and not have to worry about making bigger stuff, which could be impacted and all that and destroyed and all that. And then finally, at the end of the day, the trade-off seemed to be, hey, I mean, yeah, it might be a little bit like a little stick on there or something like that, but at the end of the day, the trade-off seemed to be pretty decent. So that is basically the idea behind establishing the decision aspects. So the idea of developing a decision criteria is basically these 5 parts. Find your problem, figure out your objectives and constraints based on the problem. After that, then you start building up your alternatives and then find out from the alternatives the consequences and trade-offs of each of those alternatives. So I hope that helps you as we start off with this, because the next 2 days, I'll be talking about basically engineering economics for the hour, and that's going to be a really big whirlwind tour. And then the final part will be more about robustness and the like. But I hope this actually got you thinking about how to formulate your solution sets by using good problems and objectives. Comments, questions?
So the consequences section is like how exactly your project or what you're doing, how it impacts, the impact that it would have on, I guess, the environment, on people, on stuff like that. And then the trade-offs is basically what you're willing to sacrifice in order to get what you want. Is that correct?
Yes. 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 Just so.
What are some questions that we can ask to better define a problem?
That's a very good question, Clay. Toyota developed something called the 5 whys. Okay. I'll put this out here for you. What Toyota used to do, and they still do, I should say, is they got into their what they call the Toyota production method or system. They said, develop out why something is the way it is. So like I used to joke with my students, say, okay, why didn't, take care of Zach, he's probably out already. Okay, but anyway, so why did you not turn on your, why did you run out of gas? Because I did not fill up the tank last night, or I didn't fill up the tank this morning. So why didn't you fill up the tank? Well, because I got up late. Well, why'd you get up late? Well, because I went to sleep late. Well, why'd you go to sleep late? Well, I was watching too much YouTube last night. I was binging on something, or I was watching a program. See, that usually will help you in keep asking the why of the why, and usually about 5 whys deep will help you get into the main problem. Usually, it's just a quick and dirty method of doing it.
Thank you.
That's a really good question, Clyde. I'm glad you asked. Thank you. Others?
So the alternatives are like potential solutions that you could implement in order to solve your problem. In the case when you're dealing with more than one alternative, when you have more than one option at your disposal, can you briefly explain exactly how you would choose between them?
Oh, sure. Okay, yes, you are correct. The alternatives are basically all the things that I am considering to solve the problem. Usually what you should do is, that's when you brainstorm. Don't deny something just because it seems really weird. Just brainstorm, figure out all the things that are possible. Now, to get your alternative, now that's also why I recommended this book, because I knew there was no way I could cover everything. But This book, Smart Choices, is exceptionally good. Dr. Keeney and Hammond and Rifa are some of the most theorists, some of the foremost decision theory therapists in the field. This is a very accessible book. It's written more for the average person, but the point they say is the following. What you do is, once you've made your objectives, you turn those objectives into a series of decision boxes. Okay, so like let's say, like I have here, cheaper, reliable, and sustainable. So let's say there are different ways of asking, but one way could be on a scale of 1 to 10, 10 being highest priority, how do you rank cheaper than Brazil? So let's say I give it a 9. I'll ask your question right now, Justine. How do I rely it? Well, I'll say that's a 9 out of 10. Okay, so reliable, 7 out of 10. Okay, sustainable, 7 out of 10. And so what you would do is, from those goals and those numbers, you normalize them and make them percentage values of each of them. Now, once you make a percentage value of that, then you could basically use that to add them up and give a ranking to each of them. So like, for example, the protein shakes, if I want it cheaper than Brazil, I give that a value in terms of what it would be out of let's say 10. The same thing with frozen insects. I put on each of them. Now, what I could do, let's see, who was the one that asked the question? Apologize. Nicholas? Okay. What I could do, Nicholas, is maybe I can dig up some of my old notes and show you an exact example. But the point of all this is basically you take your objectives and then you rank the choices by the importance of your objectives, so that the weight of the most important objectives gets the highest amount of value. And so after you add them up, it should allow you to get the highest value alternative. That's one way of objectifying. Now, there's another book that I also recommend, but sorry, let me get it real quick. There's another book that is actually more technical. The only problem is that when you go into it, it could be a little bit theoretically challenging, and that's why I would recommend a class in it. But again, if you get the smart choices, it'll give you a very basic understanding of the process. But what I could do is I can get some technical ones and also an example of how you do an alternative choice with the spreadsheet. But again, the point is, the simple answer is, by getting your objectives, you can then rank each alternative by how much they fulfill that objective, and then the final score would allow you to figure out, this is my best choice.
That makes sense.
Okay. Now, one of the 5 whys, part of root cause analysis and lean con. Yes, it is actually, Justine. It is part, yeah, it is part of lean concepts. Yes, root cause analysis. But that's actually why it's so good with problems, because you're getting to the root problem in terms of what you're trying to solve. Are you an industrial engineer? I think you told me that. I forget. Or chemical, okay. Have you taken a class on lean? I'm just curious because you seem to know a bit about lean. Okay, there you go. Yeah, they're probably one of the first things they taught you. Okay, makes sense. But yes, it is basically the problem goes to a root cause analysis. Other questions or clarifications, etc. Just in case you're thinking about it, I do want to emphasize, I am not saying no to experimental designs. I'm far from it. I think that I mean, I'm a researcher myself. I like to think outside the box. One thing I've been trying to do is figure out how do I use industrial manufacturing practices to better prevent human trafficking, because I think that it's not just going to be a domain of identifying it, but it's got to need a way of interdicting on it. But remember, when you think about the objectives, if your objective is to be pure research, then that's it. It's all pure research. Now, obviously, you've got to worry about money. But knowing what your objectives are will allow you to make a better decision when you're making your projects out. That might even be your senior project, or figuring out what you're going to do after you get out of Cal Poly Pomona, or if you should take that job in New Jersey versus, let's say, I don't know, San Jose or something like that. And again, I'm not getting any money. I don't get any money from promoting this, but I do recommend all of you to get the Smart Choices book. It's an exceptionally well-written book. Gives you all the basics, and even some basic mathematics if you really want to go into it. And I recommend it to all my students all the time when they come in for advising. I think it's just one of those books that you should have a copy on your shelf. Read through it, get some idea of how it's done, and it's just an exceptionally well-written book. And I think for your additional education as an engineer, it's just really a good option to deal with. And I think what I can end with is a story of the whale that got beached and the dynamite. Would you like to hear that, guys?
I've heard that one.
You think anybody else want to hear about it? All right, okay. You said that. Did you say, Clyde, that you'd heard it?
Yeah, I've seen the video of it. Yeah, if I'm not mistaken, a carcass of a whale was on a beach.
Yep.
Yeah. I've seen videos of it too. It was crazy.
Yeah, let's just put it this way. The reason why I mention it, I'm not going to say the whole story, but I think, you see, I have a suspicion that what happened was some guy from some department up in Washington, or it was Oregon, I think it was, said, you know what? Well, we handle issues with blockages with rocks all the time. And what we do is we put dynamite. So, well, you know, a whale carcass is basically a big roadblock. So why don't we use dynamite to get rid of said whale carcass like we do with said rocks? Well, I think, you know, in theory, I guess it sounds right. But the problem is, when we think of the actual dynamics of whale carcasses, including densities of said materials, etc., probably not a great idea. And in fact, that's what happened. Let's just say that it was a bad day to be a person in a car or around that beach that day when the explosives went off. So. Any other questions, or are we good for the day?
I'm good on questions for now.
Was this useful? Let me ask this of all of you. Was this useful, do you think?
I think it was pretty useful. I like the ProAct setup, how it lays down a sort of structure in order to get basically the bare bones of any sort of project you're working on. I think it is correct to define the problem and the objective as well as the constraints before going through the alternatives, because if you just list alternatives without having an objective in mind, you can stray from like what sort of problem you're trying to solve. So everything makes sense so far. And I feel like if I were to implement this and try to employ this sort of solution set, to employ this setup, the ProAct setup, to come up with a solution set, it really would help.
Okay.
And
again, I want to make sure this was useful and helpful for you all, because I mean, again, my big point is whenever I talk to my students is, are you solving the problem to begin with? And that's the only reason why when you asked me to do something like this, I was more than willing to do it. And I meant, okay, Justine, am I pronouncing it right, Justine? Okay, Thank you, Jesse. I want to make sure I'm doing it right. But yeah, I mean, being able to organize your thoughts before, I see students go all the time directly into the solution. And I'm like, whoa, 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 back up, back up, back up. Are you sure you're solving the problem with this? I mean, it sounds great that you're going to put this automation into it to solve the problem, but what happens at the end of the day? What happens when your mechanism has been operating for a couple of years and suddenly starts breaking down? Have you really solved the problem, or are you making more problems in the end? Yes, actually, Clyde, it's related. It's actually part of systems engineering that we normally have. We actually, one of our technical electives in industrial is actually in reliability and decision making. So yeah, a course that we take as industrial engineers. And I think most graduate courses, most graduate programs, when you go into industrial engineering master's program, require you to go and take a decision theory class. And I found it one of the most useful classes I took as a graduate student. I wish I had taken it as an undergrad as a CS major. Okay. Oh, you do, Clayton? Okay, good, cool. I do want to mention something for tomorrow. Now, tomorrow I think it was you, Nicholas, that I gave this particular file. Okay, so you'll notice that it has a whole bunch of equations and all this. This is basically a simple breakdown of all the formulas we use for my class in engineering economics. I will focus all on that tomorrow. Okay, it's very simple math. I won't get too deeply in the math other than to show you the formulas and how they kind of work. I'll probably show you a bit of the Excel spreadsheet way of using it, but I just want you to know that tomorrow when we get together, I'll be talking about how to make the comparisons in terms of economics. I will not go into other things in systems engineering. Maybe if I do, it'll be very, very, very light on it, but most of it will be based upon this file tomorrow, okay?
Yeah, for sure. Our club secretary will probably send a reminder email with that link again so that people will just have access to it, reference it.
Okay. Okay, well, unless there's other questions, I'm pretty much finished for the day.
Yeah, I'd like to thank everyone for coming. I hope this first session helped with better being able to construct a sort of solution set that would fit their individual projects. And I'm excited to hear what Dr. Placencia, right? Did I pronounce that?
Yes.
He has to say and how he explains engineering economics in a way that's, I guess, understandable, because this does seem like a very dense topic.
Unfortunately, it takes a bit of time to understand it, but hopefully it won't be too bad. And I thank you all for your patience and your feedback on this. And hopefully it does continue on to be useful for you. And also, as I mentioned, I hope it gets some good projects. And I want those of you who are on the board that we had the discussion, I hope you don't think I was being difficult about it. It's just I want to make sure that if you do something, they'll say 10, 15 years ago, wow, yeah, I remember that class from Cal Poly Pomona. They really did a great job on this. So.
Right. And just as a heads up, we haven't decided on a specific place to post the recording. Once that's decided, we'll probably send a mass email just informing people about it so that they have access to it.
No problem.
All right. Thank you guys for coming. I think I'm going to end the meeting here.
Take care all. Have a good day.
Thanks again, Dr. Placencia.